Have you ever just stopped and thought about what's really holding our modern world together? It's this invisible force we use every single second of every day, but you can't see it, you can't touch it. Well, we're about to dive into the story of the one force that, more than anything else, has completely reshaped our world in just the last 200 years. So, think about it for a sec. On one hand, you've got this terrifying, chaotic bolt of energy from the sky. Then you have this sleek little device in your pocket that connects you to pretty much everyone. And then there's the internet, a global web of pure information. They seem like they're from different planets, right? But believe it or not, they are all connected at the deepest level. And that's the answer: electromagnetism. It's one of the four fundamental forces of nature, and our journey to understand and then master it, well, it's pretty much the single greatest technology story ever told. It's a story of sparks and flows and waves and the absolutely brilliant people who pieced it all together. So our story doesn't start with some complicated circuit board or a massive power plant. Nope, it begins with a simple, kind of mysterious crackle. You know, the exact same thing that makes a balloon stick to your hair after you rub it. We're starting at the very beginning with electric charges that are just standing still. This is Chapter 1, Electrostatics. Sounds a little technical, I know, but all it really means is that before we could make electricity do anything for us, we had to figure out what it was doing when it was just sitting there. Early scientists were just fascinated by how objects could suddenly push or pull on each other with no strings attached. I love this quote because it just nails the whole challenge, doesn't it? Nature gave us this raw, untamed, incredible power in the form of lightning. And basically, our entire history with electricity has been one long quest to organize it, to somehow tame that wild energy and make it predictable, useful. And that organization, it all starts with two beautifully simple rules. That's it. These two little ideas are the foundation for everything that's about to come. Charges that are the same push each other away, and charges that are opposites pull toward each other. It's this invisible dance that's happening all around us all the time. So early on, scientists started noticing that this new electric force looked suspiciously familiar. It looked a lot like another mystery of nature: magnetism. Both forces seem to play by the exact same rules. Likes repel likes, opposites attract, and they both get weaker with distance in a very similar way. For a long, long time, they were just seen as twins. You know, related but separate. That idea was about to get completely blown apart. All right, so understanding static forces was a huge first step. But the real revolution, the game changer, happened when we figured out how to make those charges move. This is the story of how we went from a little bit of static cling to a dynamic, powerful flow. And let me tell you, the 19th century was just a whirlwind of discovery. It was like a set of dominoes falling. First, Coulomb puts actual numbers to the static force. Then, bang! Oersted and Ampere find that a moving electric current creates a magnetic field. All of a sudden, the twins were connected. Then, just a few years later, Faraday flips the whole thing around, showing that a changing magnetic field could create an electric current. You can see it happening, right? All the pieces are falling into place, leading to the grand finale with Maxwell. So what is this current they were all so excited about? Honestly, the best way to picture it is just like water flowing through a pipe. The little electric charges are the water, the wires the pipe, and their movement, that's the electric current. This super simple idea was the absolute key to directing and controlling electricity. And this process, the one Faraday discovered, is the engine of our world. No exaggeration. It's called electromagnetic induction, and almost every single watt of power you use is generated this way. By spinning magnets near coils of wire in a power plant, we create a changing magnetic field that literally shoves electrons into motion. It's that simple, and it's that profound. As you can imagine, this new ability to generate tons of electricity kicked off one of the great rivalries in science history. On one side, you had Thomas Edison pushing for direct current, or DC, where electrons flow in one steady direction. And on the other, you had the visionary Nikola Tesla, who championed alternating current, or AC, where electrons just wiggle back and forth.
Tesla's AC ultimately won the war of currents because it's just way more efficient for sending power over long distances, and that decision literally shaped the power grid we all depend on today.
So all these incredible discoveries, static forces, currents, magnetism, induction, they were kind of like puzzle pieces just laying there on the table. The time had finally come for one person to step back, see the full picture, and put them all together. And that person was James Clerk Maxwell. I mean, when Albert Einstein says your work marks a turning point in history, you know you did something big. He took all the experimental work of Faraday and others and translated it into a set of just 4 incredibly elegant mathematical equations. And hidden inside that math was a prediction that would change the world. Maxwell's math showed that a changing electric field creates a changing magnetic field, which then creates another changing electric field, and so on and so on. This makes a self-propagating wave that can just shoot through empty space, an electromagnetic wave. All of a sudden, electricity and magnetism weren't just connected. They were 2 sides of the very same coin, dancing together through the cosmos. But here's the really wild part. When Maxwell calculated the speed of these new theoretical waves, he got a number, and it was a number that was shockingly familiar to every physicist on the planet. It was the speed of light. I mean, this could not be a coincidence. And it wasn't. This was the big reveal, the punchline. Light, the very thing we use to see the world, is an electromagnetic wave. This was the grand unification. 3 huge areas of physics that had seemed totally separate for centuries, electricity, magnetism, and optics, were suddenly revealed to be just one thing. Okay, so understanding the force was absolutely revolutionary, but the next step was to control it with incredible precision. This is where we shift from the age of raw power to the age of information, the age of electronics. And the key to this new age was a special class of materials. We already knew about conductors, like copper, that let current flow easily, and we knew about insulators that block it completely. But semiconductors, they're different. They're kind of on the fence, and with just a little nudge, you can make them act like either a conductor or an insulator. This ability to be precisely controlled, well, that's the secret sauce to all of modern electronics. And this control is perfected in probably the most important invention of the 20th century. The transistor. At its heart, a transistor is just a tiny, lightning-fast electronic switch. You apply a very small electrical signal, and you can turn a larger current on or off. On becomes 1, off becomes 0. By packing millions and now billions of these simple little switches onto a tiny chip of silicon, we create the microchips that power our entire digital world. So let's bring this all home. From understanding a bit of static cling to designing the chips in our phones, this incredible journey of discovery has completely remade our planet. The legacy of electromagnetism is simply the world you see all around you right now. I mean, every time you listen to the radio, use your GPS, connect to Wi-Fi, or make a phone call, you are using technology built directly on Maxwell's discovery of electromagnetic waves. We learned how to send information riding on these waves, creating this invisible web of communication that now connects the entire globe. When you trace that line all the way back, it's just astonishing. It runs from some ancient philosopher noticing a spark from a piece of amber, through Faraday and Maxwell uncovering the fundamental rules, all the way to the engineers building our global communication networks. Our entire world is built on this one continuous story, the story of mastering a single invisible force. And that just leaves us with a final thought to chew on. We've seen how figuring out just one of nature's fundamental forces gave us everything from light bulbs to the internet in just a few generations. So it really makes you wonder, what's next? What other huge secrets is the universe just waiting for us to uncover? And what kind of world will they build?